I don't know.
Okay, it's okay. Because of the air resistance. Because, you know, the air resistance, as the pod moves upward, it collides with air molecules, and which create a resistive force, which is in the opposite direction. Okay, so
Yep.
basically work is done against this air resistance, so which cause some of the pod's initial kinetic energy to be transferred into thermal energy or waste as the heat energy, rather than being converted entirely into gravitational potential energy. So because of air resistance, okay, and you can just explain because it is in the opposite direction, so some will energy will be waste. So 100% energy is not transferred from one form to another. That's why. So you can write air resistance, which is in the opposite direction and which is allowing energy transfer not to be 100%. Okay,
Yep.
because here the energy is elastic, and when it is going up it is converting into what?
When it's going up,
Yeah,
there's resistance going down.
yeah, it is gravitational potential energy, right? As it moves up, so elastic
Yeah.
is converting into gravitational potential, but some of the energy because of the resistance is wasted, so 100% is not transferred, which because of that the actual maximum height will be lower than the answer we are getting, because we ignored air resistance in this question, right? Did we put any value for air resistance? No.
No.
That's why the actual one is lower than that. Did you get it?
Yep.
Great. Let's move to next question. So you have to write air resistance and all in that one. Um, okay, you read question number 7.
Figure 11 shows a measuring cylinder containing some water, which a student used to measure the volume of a metal ring. When measuring the volume, the student's eye was in line with the level of water. What type of error would have been caused if the student's eye was not in line with the level of water?
Hmm. What do you think? Any idea?
Is it is it zero? No, random error.
Yes, it is random error, because when reading a measurement from a scale like this measuring cylinder scale, looking from an angle rather than looking straight, it cause parallel error. Okay, parallax error actually, which is a type because the student might not look from a slightly different angle each time they take a reading, sometimes from if you are looking from high or low. So this is called random error. Okay, if the option was parallax error, then you will choose that one. Okay, because this is more specific. Okay,
Yeah.
random error is, and the other error systematic error are, these are consistent and repeatable errors which is usually caused by equipment. Okay, the things which we are using, they in because of that this is called systematic. Zero error is a specific type of systematic error where when the device does not start from the zero. Okay, let's suppose the zero is here and the device starting from here, so that is zero error. Let's go to the next question. Read question 7.2.
The student tied a piece of thick string to the metal ring and lowered the ring into water. So just one reason why the student should have used thin string instead of thick string.
Yeah, any idea?
Mm, thin string is lighter.
It is to minimize the volume of water displaced by the string, because when measuring the volume of the metal ring, a thick string would displace more water than a thin one, right?
Yep.
So this would lead to an overestimate of the ring's volume, which will make the result less accurate. So if we use a thin string, it ensure almost all the displaced water comes from the ring itself, rather than thick one. Okay.
Yeah.
Hmm. Let's see this 7.3.
Uh, the true volume of the ring was 0.44. Even without using the string, the measuring cylinder could not have given an accurate value for the volume of the ring.
Hmm. Why? Why measuring cylinder is not giving to this the correct one?
Mm, because it's not measuring the volume. Is it?
Actually, measuring cylinder have low resolution. They cannot, the scale division on the standard measuring cylinders are usually 1 centimeter cube or zero point 0.1 centimeter cube, which is not fine enough to accurately measure the change as small as 0.44. Okay, so you can just write measuring cylinder have they have low resolution. Okay, so they cannot
Yeah.
measure change as low as this.
Yeah.
Hmm. Okay, let's go to 7.4. Yeah.
Student used the balance to measure the mass of the ring. After the ring was removed from the balance, the reading on the balance was 0.02 grams. How would the student use the readings from the balance to determine the correct mass of the ring?
Hmm. What do you think? Why
Um,
or how?
well, he put it on a balance. The reading on the balance was 0.02 grams.
Mm-hmm.
So the ring should be equal to 0.02 grams.
We need to subtract it from the measured value, right? Because after removing the ring from the balance, still it is showing reading 0.02 grams. That means this is the error, right? If we add
Yes.
this, so we need to just subtract it from the whatever we get, right? The mass of the ring to get the accurate value. Let's do 7.5. If you don't get any question or anything, you can ask me, okay?
Yep.
Hmm.
The student determined that the density of the ring was 21,500 kilograms meters 3. The volume of the ring was 0.44. Calculate the mass of the ring. Use physics equation sheet.
Yeah. So what is given? Density and volume. What we need to find is mass. So whatever is given and what you need to find, just check that and check the equation in which all these three things are present.
Density equals mass divided by volume.
Exactly. Density is equals to mass by volume. This is the symbol of density, which is called rho. Okay.
So mass equals density times volume.
Absolutely correct.
So 0.44 times 21,500.
Also, you
Uh,
need to check for units. Here it is centimeter, right? And here we have meters, cube. So they should be same. If one is showing meter, the other should be meter. Or so what you can do, we can convert this one into this meter into centimeter or the other way. So let's take this 0.44 because 1 meter is equals to how many centimeters?
100.
100. But here we have cube, right? So we need to cube both side. If I cube 100, I will get, we need to, cube means multiplying it 3 times, right? If I multiply 100 3 times, I will get 6 zeros, right?
Yep.
Yeah, that means to convert centimeter cube into meters cube, I need to divide 0.44 by 6 zeros. 246. Why I am dividing? Because centimeter is smaller, meter is bigger. Whenever we are converting a smaller unit into bigger, we divide. Remember SBD. And when we convert a bigger unit into smaller, like meters into centimeter, we multiply. BSM, bigger to smaller, multiply. SPT, smaller to bigger, divide. You can remember these to memorize it. So 0.44, we divide it by this, and what we will get, we can write
Zero
it.
0.0000044.
Yeah, now you will times this with the density, because this is our volume, right?
Yes.
Hmm.
So that times
Yeah, 21,500.
so equals 0.00946
Yes, 0.00946. What is the unit? Kilograms.
kilogram.
Yes, because this is mass. So one important point, again I will highlight, if it is meter cube and this is centimeter cube, so you cannot just do 1 meter 100 centimeters, so divided by 100. There is a cube, so you have to take care of that. If there is a square, then this will become 100 times 100, right? Which
Yeah.
is just 10,000. So during conversion of units, you have to take care of the degree also, what exponent is there. Let's do question number 8. We did this one, yeah. So number 8.
The pressure increased because when the plungers pressed in, the amount of space for the air particles decreased. So
Okay.
they started crashing into the walls more
Mm,
frequently.
exactly, because you are decreasing volume, so the pressure is increasing and the particles are colliding with the walls of the syringe. Absolutely correct. And also the force is increasing. We know the formula for pressure is force by area. So if we increase force, this is like this. For pressure is force by area. If we decrease area, force increase, I mean pressure increase. If we increase force, pressure increase, because pressure is directly proportional to force and inversely related to area. They have inverse relation. Okay. Yeah, yeah,
Yeah.
that's correct. So 3 points you need to write because it is of 3 mark. You can write decrease, like you mentioned, volume is decreasing, and collision one, because they are colliding with the walls, and force is increased when you are applying force by pushing it, right?
Yes.
Okay, let's see 8.2, this one.
A fire piston is a special type of syringe that can be used to start fires. The plunger is pushed quickly downwards and compresses the air. When the air is compressed quickly, the temperature of the air increases. How does an increase in temperature affect the air particles inside the piston? The mean kinetic energy of the particles increases.
Exactly. Why? Because temperature is directly, temperature measure the average kinetic energy of the particle. Like if you boil water, the particles move faster. Even water move, right? Why? Because its kinetic energy is increasing as you are increasing the temperature, right? So when the
Yes.
temperature of air inside the fire piston it increases, the particle will move faster, and it means kinetic energy has increased. So let's do 8.3.
When the
Uh,
air is hot enough, a small piece of cotton wool in the piston catches fire. The energy transferred to the air in the piston is 0.0130 joules. The mass of the air in the piston is 2.6 times 10 to the 8 kilograms. The specific heat capacity of air equals 1.01 kilojoules per kilogram degree Celsius. Calculate the temperature change of the air.
Okay, what is given is mass and specific heat capacity. What we have to calculate is temperature. Sometimes you will get the direct formula, sometimes you won't get the direct formula because you need one more variable. What you need to use the other equation, right? You sometimes we use two equations, right? First we get one variable from first equation and then we use uh, that variable into second, right? So
Yes.
here if because we need to find okay, I think we have direct formula here. Yeah, we need to find temperature change. Check which one has temperature change from equation sheet, and all these things: energy, mass, specific heat capacity. Let me know the formula by looking at the sheet.
Change in thermal energy equals mass times specific heat capacity times temperature change.
Exactly. So change in energy equals mass times specific heat capacity times temperature change. This formula. Okay, good. What we need is temperature change. So we will rearrange the terms. So what you will get? Tell me.
Um, 1 second.
Okay, sure.
Change in mass equals temperature equals change in thermal energy divided by mass times specific heat.
Exactly. Absolutely correct. Now just plug the values. Before plugging values, check the units. Check the units. Are they same or do we need any conversion or not?
Um, they're the same.
Okay. Just this one is joules here.
Specific heat capacity is kilojoules, and the other one's
Exactly.
just like
So let's convert it into joules. What you need to do here?
you divide.
You divide.
I mean, you can divide.
See, 1 kilojoules is equals to 1000 joules. We are converting kilojoules into joules. Okay. If we convert kilojoules into joules, we are converting a bigger unit into smaller. So bigger to smaller is multiplication. Remember this BSM. If you do the other way, if you take this energy and convert it into kilo, then you can divide. But if I'm converting this kilojoules into joules, then I need to multiply it by 1000. Did you get it? Bigger to smaller is always multiply. BSM, and smaller to bigger is SBD. S means smaller, B means bigger, and D is division. Okay, so let's times it by 1000. How much will you get if you times it?
1.01, 1.01 times 1000
Hmm,
was 1010.
exactly 1010. Now it is in kilojoules. Sorry, joules. Sorry, you converted, right? Now plug all
Yes.
the values into the formula. We have same units. So before doing applying values into the equation, make sure you check the units. Okay, let me know answer after doing the math.
Okay, 2.6. 0.000. So times 10 to 10 divided by energy change in thermal energy. How do I get the change in thermal energy?
Energy is given to you. This is the energy, okay? 0.0130. This value you
Oh,
have to use, okay? Every
zero.
time they will not mention. Here it says air is hot, so that means it is thermal energy. But if it, because they all are energy, just forms are different, so you can use this energy.
Divided by 0.0000026 times 10 to 5. I don't think this is right.
Did you put this 10 raised to power -8? We have this.
Yeah,
Okay. Okay.
it comes out to 505 million.
No,
That
I think no, that's not. How is that possible? Let me see. No, an answer sheet I can see. The answer is 595, 495 degrees Celsius. Can you check it again? I'm also gonna check it my side. Maybe you made some. You are using calculator, right?
I don't have it on me. 0.0130 divided by 0.000000026 times 10 times.
Let me show you here. Like if you multiply, did you try it?
Mm, yeah, I got 5.
Okay, it's not five something. Let me show you what. If even you use this is the question like 2.60 if you multiply it 1010, so 2.60 times 1010 will give you 2626. I'm ignoring this 10 raised to power -8 because we can do it later. And numerator we have this 0.0130. If we divide these two numbers 0.0130 with 2626, we get 4.95 times 10 raised to power 4.9504 something, and we have this 10 to the power -8 here. Okay, this
Yeah,
is here, this is what we are getting. And if I take it in the numerator, I think you may have learned about this maths in maths. If you take this in numerator, this negative sign will turn into positive. So this will become 10 to the power +8, and this is 10 to the power -6. So what will happen? This 4.95 You have now 4.95, and when you have same basis, we add power. So 8 plus negative 6 will give you 2, right?
Yes.
And when you times 4.95 with 100, you will get 495. And that's what your answer is.
If you don't understand it, ask again.
What are you putting wrong in a calculator? Did you put all the values correctly? This 0.0130, everything?
I did. I
Did
got
you?
0.0000000000026.
Oh, I think. Did you put negative 8 or positive 8?
It's -8, right?
Yeah, it is. Then how you are getting such a big answer? This is the only. Okay. You plugged everything together, right? One time?
Yeah. Yes.
Then operation can't be wrong if you plugged everything. What is
Just do
wrong?
the again.
Yeah, just do again. And
I won't be able to do it most of the time because higher maths.
sorry?
I do foundation maths. Most of the time, these are higher maths questions.
Yeah.
I do foundation maths, so I can't learn it.
Oh, okay. So in maths you have taken foundation.
Yeah.
That's why. See, what whenever you have this type of question, what I prefer, I would like whenever you have 10 raised to power something. If you have exponent number, forget about it and just do these numbers. And you can do them separately. Like I think there is lot of mess. I will write it again, okay, for you, and then you plug it again. Uh, so we had this 0 point. I'm just writing the calculation part because other part you got, I know. 2.60 times 10 to the power negative 8, 1010. This is our equation, right?
Yep.
Can you check again putting it?
Mm,
Because in calculator you should get it correct.
I don't have my calculator on me right now.
So what are you using?
Phone. The phone calculator.
Oh, okay. Obviously, then it is going to be wrong. You know what? When you use the calculator like scientific, they are built in such a way that if you put all of them, they will use the BODMAS rule. Your phone calculator is not using that BODMAS rule, na? Do you know that PIDMAS or BODMAS? It is said in. Do you know that
Yeah.
rule? Yeah,
Yeah.
see, whenever you are using your phone, go stepwise. You can't fit all the whole equation. I thought you are using scientific calculator. Only when you are using scientific calculator, you can put whole equation at a time. Always follow this rule, bod mass. What is that? According to this, what comes first, multiplication or division? Because here we have these two. Because in division and multiplication, both of them you can apply anything. So let's multiply first, okay? You need to multiply these two first, then you can divide, right?
Do you
Yeah.
want him to go and quickly get his calculator?
Only in this one, always go stepwise, okay? I got it now, that's the problem. If you are
Do you
using
want him to
scientific,
get his calculator?
yeah. So first multiply these two, okay? Now go stepwise, multiply, you have to first multiply.
He's just going to go and quickly get his calculator.
Oh, okay, he has it?
He has a scientific calculator. Stupid boy just didn't bring it from
Yeah,
next door. He's
oh,
just going to go and get it.
okay, if he has,
What I'm finding
hmm,
is this keeps coming up that he hasn't got. What happened was he was in higher maths,
okay,
right? He was in foundation maths first, and then because he was finding it too easy, we moved him up to higher maths. And
okay,
in his mock exam, he got 2 marks less than he needed.
Oh,
So they put him down to foundation. But stupidly, they didn't put his sciences down to foundation. So
okay.
we're finding in chemistry as well, he can't do the calculations, he's getting stuck. So
Yeah.
I was actually going to ask you, because you do maths as well, right? So
Yes.
if you could maybe cover the, I mean, what areas, what calculations does he need, or
Yeah.
what
He,
part of
yeah.
higher maths does he need to learn that maybe you could teach him in the next session or something?
Yes, yes. I will take on like exponent. He need exponents, how to do exponents and all. He need operate. I will just quickly go through operations. I mean, multiple operation questions. You know,
Multiple operation, okay.
um,
So do you want
division
me to
calcul. Hmm.
division? Did you
Sorry,
say
decimals, decimal division, and
decimal? Okay. So do you want me to print off anything for him so that you can work on with him? Is it maths higher past paper, or do you want me to well, do you want to work with the books that he has and I can send you the pages?
yeah. Or I will check it after the class and send you if something is needed to print.
Okay, perfect. So if you send me exactly what you want to do with him, so
Hmm.
the calculations that he'll need in a higher sciences, if you can teach him that, and then going forward,
Hmm.
after his exams, I'll have you continue tutoring him with the higher maths as well. Then,
Yeah, this is really important.
yeah, because
Like
this keeps because even with
if
chemistry,
you
he
put
wasn't.
this exponents once into calculator, you might confuse. You should also have an idea if I'm doing it correctly or not, even if you are allowed to use calculator.
Yeah, no, so they should have a scientific calculator with them, and this stupid boy just failed to bring, forgets to bring these things unless I nag him. This is why I sit here with him half the time
Hmm.
because he's so scatty with everything. But I need to cook today, so I'm leaving him to you. But yeah, if we could maybe, if you could send me whatever you want to
I
work
will
with
make
him.
short notes of all the
Yeah,
all the math which is needed for this science,
yeah, please.
and I'll send
Okay,
you and you can print it.
okay, perfect.
Hmm.
Thank you.
Okay, thank you. Yeah, and now if you put all of this into your scientific calculator, you will get the correct answer. Okay?
I got 495.
Yeah, you got it. See? 495. This is the correct answer. Okay. Uh, let's do number 9. Read question and look at the graph. And we have question here. And then we will do 9.1.
Teacher investigated the radiation emitted by two different radioactive sources, A and B.
Hmm.
Figure 14 shows a radiation detector positioned near one of the radioactive sources. The teacher measures the count rate at different distances from each radioactive source. Figure 15 shows the results.
Yeah, let's see question. Explain how figure 15 shows that source A only emits alpha radiation. Source A, investigative radiation emitted by 2. So this is the graph from source A and this is from source B, the dark line.
Source
See?
A shows because it stops at 553 350 count rates per minute, which is its maximum.
Yeah, alpha particles have a very short range, few centimeters, and if the count rates drop to the level at short distance from source, it indicates alpha radiation. So yeah, this is the region. You can explain it also. Uh, yeah, so because it is just traveling 3 centimeter, if you see, because from here to here, and count rays is decreased, alpha radiation has a short range. This is the main reason. Okay, next question. 9.2, let's read it.
Explain how absorbing material could be used to show which type of radiation emitted by source B. Oh, you can use
Hmm.
it's not going to be alpha, that's already done. I think beta passes through paper.
Beta passes.
Yeah, passes through.
Beta
Or is it?
radiations, they do not penetrate. Only gamma will. Okay.
Mm,
So we need to use an aluminum sheet because it allow other materials, that beta would be, stopped by if you use a sheet of iron or lead or a brick, that will stop it. So that's why you are supposed to use aluminum sheet, because if we place a thin aluminum sheet, this will allow beta and gamma radiation, gamma radiation to penetrate or to pass through.
it
Okay.
passes through aluminium, or
Ga-
does it get stopped by aluminium?
Gamma will pass through, but
What
beta
about
will
beta?
not. Okay.
Yeah.
Hmm. Okay. So, and also in this question, it says, like you said here, because count rate is less for on short for alpha radiation, because alpha radiation have like low penetrating ability, right? That's why it was alpha. Let's read 9.3.
So just one safety precaution the teacher would have taken to reduce the radiation dose the teacher received. Staying away from the experiment.
Yeah. Staying away,
Um,
like if you have to perform the experiment and also take some safety precautions, what then what?
wear PPE equipment. Not PPE equipment. Safety.
Wear a lead apron. Okay.
Lead 8.
L- yeah, lead apron. So also you can maintain the distance between the source of radiation. The teacher should maintain the distance between the source of radiation, right?
Yeah.
And we can limit the exposure time. Okay.
Yeah.
Hmm.
So
And we
just
should,
one
yeah, next. Okay.
safety precaution that the teacher would have taken to avoid being contaminated. Not
Which one we are doing?
9.4.
Okay, 9.4. Yeah, I got it. Okay, I thought we did this. Yeah, 9.4. What do you think?
One safety precaution to avoid becoming contaminated is, well, the same thing, I guess.
Yeah,
Keeping
exactly.
keeping a safe distance from the source to limit your exposure to the radiation.
Yes, it is same, almost same. Okay. Next question shows how the number of atoms of a radioactive element in a sample varied with time. So we have time here. We have to determine activity. Okay.
As time in seconds increases, number of atoms decreases.
Yeah, this is what is happening. Okay. So determine the activity of the radioactive sample at 300. Do you know how to find that? I think.
Uh,
Let me take the screenshot.
yeah.
Yeah.
Find how many number of atoms are first, right?
There is a whole formula. Do you know how to find slope in math?
Slope.
Yeah, it is similar
Um,
to that. See, it says activity of radioactive sample at what time? 300 seconds. Okay.
yes.
So 300 second is this, right?
Yes.
And if we make a tangent here, tangent means any just a straight line which is touching this point, like this. This is called slope. Slope gives us steepness of any graph, how steep the graph is. It just tells us about the steepness of the graph. So at this point, what we have given is 300, and the formula to find the activity is change in number of atoms divided by change in time. Okay, so change in number of atoms, if we take any 2 point, like if I make a straight line, and at this straight line, if you take let's say at 300, like this tangent, why I draw this tangent, it is telling that as we are assuming that here it is as a straight line. Okay, because from straight line graph, if this is 300, we can assume this point, right, at 300, this is suppose one of my point, and other point, if I take other point, let's say at 400, at 400 the graph this 2, and at 300 I should make a straight line not to get wrong answer. 1 minute, let me just erase this. I will make us try to make a straight line. Okay, this is, yeah, see, the formula for activity is change in number of atoms divided by change in time. So why I did this, how do we find change? By subtracting two values, final and initial. So suppose this is my final, um, I will just take these 2 points and subtract them. So first
At
I'll
300 point. At 300 is 2.8 times 10 to the power 23.
2.8 times 10 to the power 23. Sorry, 2.8 times 10 to the power 23 minus this, which is 2, right? 2 times 10 to the power 23, and then we divide it by 400 minus 300. Okay, so if
At
we just
point 8
subtract,
to the
yeah,
power 20.
exactly, zero point 0.8, this, and this is 100. So if we divide zero point 0.8 by 100, what we will get? 0.
1 sec.
Okay,
Um, 0.8 times 10 to the power 23 divided by 100 is 8 times 10 to the power 20.
exactly. So this is the activity. Okay, this
Yeah.
is also the problem is that you are not taking higher math and higher physics. Obviously you need physics, math to do physics. This concept is also a concept of math, slope or gradient. Did you have you done gradient in math?
That was one of my only weak points in maths, but I
Gradient.
know what it is. I know how to
Okay.
do this equation. This one's pretty easy. I don't need any knowledge.
You get it?
Yeah.
Okay, okay. This formula, whenever you are finding change between two, like if you have a graph, change on y-axis divided by change on x-axis, this is how you have to do. Okay, take two values. Did you get why I draw this straight line? Did you get it?
Yeah.
Okay, I have taken corresponding x and y values. Okay, and always keep y values in the numerator and x values in the denominator. Like I have taken 400 and 300 in the denominator. Okay, and these
Yes.
values on the here numerator. Okay, also it is asking about the units. This is BQ, capital B and lowercase q for the activity.
Yep.
Let's do number 10.
What color is the insulation covering the live wire and the three core cables?
This
The
is
live
this
wire cable is connected by a fuse inside a plug. Fuse contains a wire that is designed to melt when the current gets too great. What color is the insulation covering the live wire in a three core cable? Think.
it is
Is it
brown.
brown?
Yeah, it is.
Fuse is a line, then a block, or a rectangle, and then line out of it.
Exactly, a rectangle and a line out of it, just like this. Okay,
Yeah.
let's go next one.
The fuse wire melts when there is a charge flow of 2C for 400 milliseconds. Calculate the current in the fuse wire. Use physics equation sheet.
So what is given is charge and time. We have to find current. So we need a equation with charge, time and current.
Charge times current. Charge
Let's
flow equals current times time.
charge flows is equals to current times time, right?
Yeah.
Yes, we have to find current. So the equation will become
So current equals charge flow divided by time.
exactly. Current is charge divided by time. Just plug the values. Check the units before doing it. Yeah, units are correct. Oh, no,
So
this is milliseconds. See, this is milliseconds. The unit should be standard. The standard unit of time is seconds, so it should be seconds. Okay.
yep.
How do we
So
convert
0
milliseconds into seconds?
is divided by 1000.
Exactly, 1000. Yeah,
So 0.4 seconds. So 2 divided by 0.4
exactly. 2 divided by 0.4. This will give you current.
equals 5 amps or
Very
5
good.
A.
Yes, 5 amperes. That's absolutely correct. I think, yeah, we are just left with two more questions. Let's finish it. I
When the
think,
fuse
yeah, okay,
when the
go.
fuse wire is at its melting point, the additional energy needed to melt the wire is 1.02. Specific latent heat of fuse wire is 60 kilojoules to kilograms. Calculate the mass of the fuse wire. Use physics equation sheet. So mass, specific latent heat.
Yeah, exactly. Specific, and we need mass, and we have given energy.
Specific latent heat.
Mass, energy, and latent heat.
Yeah. Latent heat, latent heat, latent heat, latent heat. Oh, thermal energy for a change of state equals mass times specific latent heat.
Exactly, that's correct. What we need is mass, so this will become,
E equals m times L. So mass equals E divided by L.
yes. Just check the units and plug the values. If units are same, are units same?
Thermal energy for change is 1.02 joules, but the other one's in kilojoules.
Yeah, so let's make this kilojoules into joules. So what you need
So
to do?
kilojoules divided by 1,000.
No,
Not
bigger to smaller is always multiplication. Just remember BSM and SBD. Kilojoules is bigger than joules. So we are converting a bigger unit into smaller. So multiply.
by 100.
No, 1 kilojoule is 1000. Yeah, whenever there is kilo and you have to convert it into the other one, it is mostly 1000. So 60 times 1000, which is just,
60,000.
yeah, 60,000 joules. Now just plug the values.
60,000 joules divided by
We have to
uh,
divide, okay, yeah, 60,000
6.
joules.
It's 1.02 divided by 60,000.
Exactly. So the answer
That
is,
is 0.000017.
yes, absolutely correct. Okay. Let's quickly do the last question of this paper.
Um, the calculation in question 4 assumes there is no energy transferred to the surroundings. How would the time taken for the wire to melt be effective if some energy was transferred to the surroundings? Your reason. Time, if e- energy was transferred to surrounding, time taken would increase.
Exactly, because when energy is transferred to the surrounding, it means the energy is lost as a heat. So there is less energy available to heat the wire itself. So it takes a longer time for the wire to reach its melting point. Okay, so it will be this one, the time would increase. Um, do you have any question?
No.
So let's quickly let me just tell you the main points that you need to remember whenever you are doing any math question in physics or any math question, or you have to apply any equation. Before applying equation, you have to check the units, make sure units are same. This is really important. After that, check what is given. Suppose you have given volume and let's say density, and you have to find mass. Now you will go into the sheet, you will find these three things: mass, volume and density, and then you will check in which formula you have all these three things. Density is equals to mass by volume. Then you will rearrange this equation according to what you have to find. You need mass, so you'll keep this mass here and arrange the equation, and that's how you get the answer. Okay, also if you are not using your scientific calculator, you cannot plug a whole equation into your phone. Always use scientific calculator when you are doing math, or otherwise follow this rule: BOD mass, bracket, then indices, bid mass actually, then division, then multiplication, then addition, and then subtraction. You have to follow this rule, or
Yes.
which is called order of operation. Okay, any question?